Hi guys, this is the last step in typical machine learning process. I won't say this is the last step, but in a high level steps, which is data visualization, transforming results into visual graphs. So let me give an overview of visualization of your learning results. I am Dr. Ganesh and thank you for watching these videos. Visualization is nothing but how do you want to see your results looking like using plots which are easier for you to understand and make sense than looking at numbers. So let's take classification visualization as the first one. So for example, a classification report could look like this. You have some numbers, occupied, unoccupied. And in the previous video, we have seen precision, recall, F1 score, etc. as the key measures. So we can see here how precision looks like, how recall looks like for various values. One of the common uh, visual that we may want to plot is the class prediction error. You see the first bar, which is apple, but there are certain items, certain apples which are detected as a kiwi, pear, banana, or orange, whatever, some of them. So class prediction error is a chart that shows the support for each class in the fitted classification model displayed as a stacked bar. Each bar is segmented to show the distribution of predicted classes for each class. So you are able to understand how it predicts. So you see the last plot, for example. Many of the oranges are predicted as apple and many are predicted as pear and very few are predicted as banana. We could also use precision versus recall curves that typically gives us an idea about how your algorithm looks like in terms of precision and recall. And naturally, confusion matrix is a very popular way of measuring your uh, visualizing your results. So you can see examples of confusion tests here. What about regression visualization? Prediction error plot. In regression, it's a measure of how well the model predicts the response variable, how much error you have. Another measure is the residual plot, because a linear regression model is not always appropriate for the data. You should assess the appropriateness of the model by defining residuals and examining residual plots. So what is residual? The difference between the observed value of the dependent variable and the predicted value is called residual. Each data point has one residual. So residual is nothing but observed value minus predicted value. Both the sum and the mean of the residuals are equal to 0. That is sigma e equal to 0 and e bar the mean is equal to 0. There could also be plots specific to certain parameters in your regression. For example, your regression has the slope and y-intercept, the alpha, beta, etc. So we could see how well we selected alpha for various values of alpha and see where it gives you minimum error. So what is alpha? If you take RP as portfolio return and RM as a market return, your RP minus RM is what you want to plot which is alpha, the y-intercept, plus slope times x times Rm minus Rf. So the alpha is nothing but the y-intercept, and we want to see how well your alpha is selected. So alpha selection visualization demonstrates how different values of alpha influence the model selection during regularization of linear models. Alpha increases the effect of regularization. So if alpha is 0, there is no regularization, and the higher the alpha, the more the regularization parameter influencing the final model. What about clustering visualization? So for clustering, a fundamental problem a step is to determine optimal number of clusters to which data may be clustered. And we know clustering is a type of unsupervised learning. So the elbow method is one of the most popular methods to determine the optimal value of k. K is nothing but the number of clusters if you take an example algorithm as k-means clustering. This method consists of plotting the explained variation as a function of the number of clusters and picking the elbow of the curve as the number of clusters to use. So in this example, it looks like 8 is a good value to go with. And from the fit time perspective, 7 is also a good value. It fits, it fits very fast. There is also an plot use called Silhouette visualizer. The Silhouette coefficient is used when the ground truth about the dataset is unknown and computes the density of clusters computed by the model. The score is computed by averaging the Silhouette coefficient for each sample, computed as the difference between the average intra-cluster distance and the mean nearest cluster distance for each sample, normalized by the maximum value. It gives you a value between 0 and 1 and minus 1, where 1 is highly dense clusters, minus 1 is completely incorrect clustering. Then we also have intercluster and intracluster distance maps. So you see I have made 3 clusters here, a green cluster, yellow cluster and the red cluster. The intracluster distance is nothing but something that measures the distance between two values of data points which belongs to the same cluster. Whereas the intercluster distance measures the distance between two values which are from two different clusters. So this is also a useful way to analyze how your clustering performed. And there are many other visualization methods. We don't go to that extent, including text visualization. For example, you have text classified into different values here. So the TSNE corpus visualization, which groups them into different groups. Or the token frequency distribution. So how frequently one particular word is occurring. For example, 2016 in this example occurred more than 150 times or around 150 times. Whereas a word such as try or new occurred only a few times, less than 40 times. So there are different ways of visualization. We have seen only a glimpse of it. So remember, the if elbow method and Silhouette coefficient visualizer are most common for clustering, root mean square error plot is the most commonly used measure for visualizing how your regression works. And confusion matrix, accuracy, and all sort of those values are used to visualize how your classification works. So choose the right visualization method for the right algorithm. That there are also feature visualization, for example, rank features, feature importance, recursive feature elimination by eliminating a feature, how my score looks like, etc. etc. With that, let me thank you for watching my video. Feel free to give comments, feedback, like and subscribe.